I'm Rob. I like to think of myself as an innovator. Thinking outside the box might be a better way of saying it. Sometimes I have an idea for something, and it turns out to be impractical or flat out will not work. But sometimes it works out beyond my expectations. I like to build drums. My goal is to build each specific drum and make it unique, and if possible, carry that drum's theme through the whole drum build. That could be colors, wood type, or the drum hardware. My inspiration for carrying themes through a project comes from Frank Lloyd Wright. He didn't just design floor plans. He designed that specific house for that specific piece of land with specific furniture, accent pieces, down to carpet, and make it a better design in the end. Here is a basic example of what I'm trying to say. This is one of my first drums. Notice the cutout on the side of the shell. I use that same cutout shape, or arc, on the lug. A small detail, but in the end, I think they complement each other very well. This video is about a crazy idea I had for a different drum rim design. I've never seen or heard about a rim built this way, but it is certainly possible that I've missed it and someone else has done this before. Here are some other rims I have built. One is layers of wedges. The layers are stacked like bricks to give it more strength. The other design I've done uses a puzzle joint to join the pieces together. It carries the puzzle theme through from the puzzle drum I did previously. So we're into VCarve Pro. It's my design software for the CNC stuff, and this is where I designed the whole project. First, I'm going to show, I already mentioned how I had done some rims in the past. Here's the one where here's the brick pattern for laying out the staves or the wedges, I'm going to call those. That was the first one I showed, and then of course the second one were the puzzle joints, so they join together. I copied these from the actual projects I did before, so those are the real ones I used to design those rims with previously. So now, what I want to do a rim with staves or slats going diagonally around the rim. So basically there's the rim, these squares, and keep rotating around. I've got another shot which shows all of them, which this is just a hodgepodge. It makes no sense, really. Let's unshow that one. So here's basically that same little stave we saw before, that purple. And then there's another one here that's rotated a little bit, rotate a little bit, rotate a little bit, and so on. So I'm getting ahead of myself. So go back to the staves here. My thoughts. I wanted to have these at 22.5 degrees. So why did I want to have that? It's 22.5 degrees, which is 90 is, of course, straight up and down. 45 is exact half of that, and this is half again. So I'm trying to keep it a little bit consistent. The rim will be about 1.25 inches tall. That's actually, I've already built some leeway into that. It's not, doesn't need you that much. And if you look close, it goes a little below that and a little above that on both sides. So I should have a little extra just in case I need it. When I rotate this sideways, that's 4.35 inches long, 1.5 wide. This part here, to get the different shape, you can't have these be flat and go around the drum. There'll be big gaps. It doesn't work that way. So I spent a lot of time trying to figure out the math on how to get that to work. And in the end, I never really found a formula to how to make this work once you do diagonals and getting it to work out right. So I did trial and error, and I did a lot of measurements with the software. And I'll go through that. Now, let's first talk a little more about this. So to find out the number of staves, I measured from the distance between staves at that angle, and we get 0.9253. The rim it's 14 and 16, the size of the ring here. So the inside, I went 14.25 to kind of get the number I'm going to use, since I can't use two numbers for the measurement. So I went 14 and a half. What did I say? So I'm going to open up the calculator real quick. So 14.5-inch circle times pi to get the outside measurement, the circumference, and divided by, what was that number? 0.9253. 9253 equals 49 point something. So I went 49 staves or slats around the drum. So if you go to the next step, I'll just close that down. showed this before, so we have 1 here, 2, you count around, that's 49. So that's to get the measurement right, to look aesthetically pleasing is what I did. So, but, like I said, this measurement here and the inside and outside edge, how did I get that number? So I already recorded once how to calculate these angles once, and I listened to the recording and it didn't even make sense to me, and I'm the one who came up with this crazy mixed up math. So I'm going to do this again. I might actually have both explanations. Maybe two will be a better way of explaining it, but it's a little crazy. So the basic thought, outside circumference of a 16-inch circle here, and inside is 14-inch circumference. So if I get the total length of this divided by 49, I want that to be this point to this point right here. So if I get these and then I resize them, well, keeping the height exactly the same, and if I resize just the width, so let's just take this percent and go 95% to explain what I'm talking about. This distance right here changed by me doing that. So before, the length of this was from that point to that point. That was 0.9234. And now it's going to be 0.8772. So I'm going to resize these to get the right outside and inside circumference, then measure this distance right here, and that'll be that distance right there. So let me undo what I just did there, because I don't want to lose that. And let's go over the calculator. The outside edge is 16 inches, so 16. And to get the circumference, we multiply times pi, so times 3.14 equals 50.24, and there's 49 slats, so divided by 49 equals 1.0253. And the inside of the circle is 14 inches times 3.14 equals 4396. So what's that? 7 inches less than the outside, the circumference. And we're going to divide that by 49 equals 0.8971. So we'll document that and go back into VCarve Pro. Up there I documented my notes, and then over here I've done that already too. So again, how I did this, highlight this whole stack. Don't need the whole stack, I guess, just need a few. But so now I'd go and make sure it's not linked right here. So all I'm doing is changing the width, not the height. And you can see I already changed that there. But if I was going to change that to, let's just do 17. And if you hear my dog in the background barking, it means UPS truck's outside, and she loves to bark at UPS. And notice it's a little off now. So let's go back to where we were. So when I resized it to get that right height, and then all I did was measured. We're going to get 0.34. And that's where I documented that, 0.34. And the same thing here. This one actually made it bigger because before I was I forgot, 89 was it? 0.9 basically? I forgot the number there, but anyway, I resized it to match up to that box, which is 1.025. And we'll measure that one again. And we get 0.3885, so basically 0.39. If I want to measure the angle, which I'll need that later when I'm out at the table saw, I'm going to go here and here. Notice right here the angle. That comes out to 1.9 degrees. And again, I measured these and these two, so what the heck, let's do all these measurements. .39, as you see right there it was, 39. And we'll do another one. And that's 0.34, a few decimal places on there, but that's 0.34. That's how I got to those measurements. Hopefully it makes a little more sense after this explanation compared to the last one. I'm a little out of order here, but here's a picture of the slat. You can notice it's a little bit thinner on the left side than the right side. Now that I've explained my quasi-math and hit-and-miss math I'm using here, I'll show what I'm trying to actually build with that. I'm building a jig, and I showed you the staves already, the circle of staves, slats. I go back and forth between the words stave and slat. You'll have to forgive me on that. But each one of these, I want to have the left edge is going to sit in a pocket. I'm going to drill a little, carve out a little pocket to catch that edge so they'll fit in there evenly. So let's show the base of the jig there. Oh, and I've resized this, so it's not going to look good. Let's just take here's a good example. So this would be a single stave. It's going to catch that edge right there and be lower here than higher here at that diagonal at 22.5 degrees. Next one to fit in that one, go in a circle around. And here's the actual pieces there'll be. There'll be a piece, an outside ring, that'll be a ring, an inside ring there, and the base that they screw into will have these slots in it. Alignment holes that you'll see later when I drill these, so I'll drill those holes into both this outer ring, inner ring, and the base, so I can get everything to line up perfectly. From there, let's go ahead and look at a 3D rendering of how it's going to look. But in the end, I did not do it. The 3D rendering makes it look like it's one piece. I did not do this one piece. I was going to go buy some MDF, make it a one piece, and I went to sticker shock when I saw the price of MDF. Let's see what this looks like. Okay, now that's done cutting out. I'll double click the outside and the inside, and that's what the jig is basically going to look like. You can see the pocket there, see the slat. So this one actually is the straight up and down, the 90-degree one. So slat would fit in that pocket there and go up and hit on this outside edge. So there, it's going to be held in place by 3 points of contact. I'll mention that later again, probably. But the next one will fit here, the next one here. Again, 49 slats are going to fit there going around the circle. So now that I've given an approximate explanation of that, we'll go out to the CNC and watch how it's cut out in the end. For clamping down this project, I did it a little bit different. I drilled 2 holes in the middle of my blank, which it's going to shape like a donut in the end, so this part's going to get cut away. So I put a couple bolts in the middle there, and I will put the nut on top, and I will slide it into the T-slot. So that's clamped down the middle part. That will be constant through the whole project. And then I will clamp down the outside 4 corners, and then I'll cut out the outside ring and remove that part, and then clamp down the outside again, cut out that ring, clamp down the outside ring. So I'm not using any tabs to hold things down, but I am holding the inside and outside constant. So it works pretty good, actually. Before actually cutting out any of the rings, I'm going to drill some alignment holes. Once I have the base cut out in a separate cut, which my video got corrupt, so you won't see that, but no big deal. Those alignment holes will be used so I can clamp everything and align everything exactly right. And now we're cutting the outside edge of the outside ring. I'm only taking off a 1/16 of an inch per pass. This is OSB, it's kind of delicate, so I figured I'd take it easy and try to get a better finish on it, which in the end I did get a decent finish considering it was OSB. I had some problems with my video camera on this, so we're not going to see every single cut, but the basic thought is first I cut the outside edge of the outside ring, then the inside edge of the outside ring, Then we'll cut the outside edge of the inside ring and the inside edge of the inside ring. I hope that made a lot of sense because it's kind of hard to say and I will screw it up if I try it again. And here are a few shots of what I'm calling Jigzilla. Pretty complex jig, has 49 slots to hold the 49 staves, keeps everything aligned just right. When you put your slats in, it has 3 points of contact, the bottom on the outside, the middle on the inside, and the top on the outside again. So it holds each stave relatively in place. It's nice and snug. I'm optimistic how this is going to turn out. For the glue up, I'm using a totally new adhesive to me. It's relatively unknown in America. I think it's moderately popular in the UK and other places. It's called Cascamite, powdered resin wood glue. Obviously from the name you can tell it's a powder. You put in 2 parts powder to 1 part water and mix it up thoroughly for a while. And you get the consistency where it's pretty much like a white wood glue that we're normally used to working with. The big advantage that Cascamite should have over traditional woodworking glues is the long working time, up to 2 hours so the temperature is right. That's a big deal to me. I've been doing a lot of complex glue ups that take time, and like this one, I've got 49 staves here, and by the time I've glued up and put them in place, when I do the 49th one, the first one, there's a good chance that glue is already set up and I can't make adjustments and tweak it a little bit. So that long working time is a big deal to me. Now that I've applied the glue to all the staves, it's time to put them in the jig. It's pretty simple, really. You can see the slot that the base goes into, holds it nice and steady at the right spot, and keep going around and adding them in 49 times, and we'll have a complete circle. Now that all the staves and slats are put in place, it's time to clamp it down nice and tight. I made this big donut, or what are we going to call this thing? I'm going to call it a donut, I think, out of 2x6s. Cut it at the angle so it comes out right. And then I surfaced each side on the CNC so it is very flat, so it'll apply even pressure around the whole future drum rim. I'll clamp 4 on the outside and then 4 on the inside, and then we'll wait 24 hours and I'll pop it out tomorrow and look and see how this comes out. When I designed the drum rim, I put those 49 slots in the bottom of this jig. The thought process was, as it applies pressure down with this clamp, it'll force those in place and apply even pressure, and they won't slip around at all. It's now unclamping time. What have I learned? First thing, this is going to work, but not today. I see the potential, but I made some mistakes, and I'm going to learn from them. First issue, the donut that I used to clamp down the top, it slipped because of uneven pressure on one side, and when I took it off, I could see already there was a big gap on one side. The piece broke when I took it out, but I know why, uneven pressure. I'm going to fix that. I'll get to that later at the end of the video. I need more Cascamite when I put it on, and it needs to be a little wetter. I only put it on one side and I put it on, and by the time I got to clamping, it was still tacky. It did not set up, but the wood was dry and it pulled some of the moisture out of the Cascamite and became much thicker than I wanted. So next time, I'm going to put Cascamite on both sides, and it's going to be a little thinner when I put it down. The piece did break when I took it out because of that crack in it, and I glued it back up. And you can see some sections of the piece here where it looks very good and some where there's some gaps in there. And again, I think I know what caused this, so we'll get to that next time. I did put the piece on the CNC to skim off the top and the bottom so it's nice and smooth on those both edges. And I put a existing drum rim I have next to it, and you can see I've got a little extra gap to work with, so that's good. To help with getting more even clamping pressure from the donut, I carved slots on the top of the donut, just like you'll see on the Jigzilla. Those should match up with the slats and catch in that so I can apply more pressure and it should not slip at all. So hopefully that will fix the issue with the clamping pressure. This video is already bumping 20 minutes long, and I still don't even have a workable blank yet to make rims with. So we're going to call this part 1 of the video, and hopefully in the next week or two, I'll have time to put out a second video. My goals for that video are to glue up another blank that hopefully will be better, good enough for a real rim. And once we have that, then I will skim the top and the bottom to get it flat on the top and bottom, and I'll cut a drum rim out of that. So, thank you for watching. If you enjoyed this, please click like and then subscribe, and I'll see you in a few more weeks. Thank you for watching.